Hello viewers, my name is Mr. Adebanjo and I want to welcome you to this video. In our last video, we talked about, we have started talking about some terms that we have in our uh, set theory or sets. We have talked about universal sets, we have talked about empty sets. So if you have not watched that video, please go back and watch the video so that you can catch up with us. In this video, we'll be talking about subsets of a set. Subsets of a particular set are just like a children to a particular set. Let me use parent as an example. God that we have parents and the children comes from the parent. So we can say the parent is the universal set and their children are subsets of the parent because they come from this parent. So in this case, now we said that this is the subset is the children or is the child or the children of a given universal set, and we use elongated C to denote subset. That is, all other given sets are inside the universal set. That means those sets are subsets of that universal set. Look at this universal set we have here, having elements A, B, C, D, E, F, G, H. And we have set X, having elements A, B, C, D, E. You can see that all the elements in set S are also in the universal set E. A is here, B is here, C is here, and D is here, and E is here. So that means set S is a subset of universal set E. And how do you write that? Set S is is a subset rather of the universal set. Also look at set Y having elements A, F, G, H. You can see that all the elements here are also inside the universal set E. So that means set Y also is a subset of the universal set, and that's what you're having here, that set Y is a subset of the universal set. But let's look at set Z having element B, E, J, K, I. You can see that J, K, I are not inside this universal set E. So that means not all the elements in Z are also in this universal set. So that means set Z is not a subset of set universal set. So that's why you have the elongated C, you now cross it. That shows that set Z is not a subset of set E. We also have another terms in set which we call union. Union is the combination of two or more sets. When you're combining the element of two or more sets together, that means you are finding their union. And we denote that one by elongated U. That is the symbol for union. If I have set A having 1 to 5, 1 to 6, and having set B having element 5, 2, 2, 7, 1, 3, 2. If I'm to find A union B, that means I'm to combine the element of set A and set B without repetition. You can see you're having 2 here, 2 here, and 2 here again. So you don't need to repeat 2, 2, 2, 2. No, just write just 1, 2. So you combine the elements A and B together without repetition. That means you have 1, 2, 3, 4, 5, 6, 7 as the A union B. You also have intersection. That means when you have two or more sets, you want to find intersection between them. What is the common element in between all the given sets? In this intersection here, intersection is the intersection of two or more sets as a result of a set that contain only common elements in that set, and it is denoted by elongated N. If I have set S having Ada, Olu, and Akpos as the elements in set S, and have set C having Ejiro, Akpos, and Ilua, it's called as there's an element here that's also in set C as well, which is Akpos is here, Akpos here. So that means S intersection C is Akpos. That means the only element that is common to set S and set C is what? Akpos. So that means you are finding intersection of between two or more sets. You are trying to look for what they have in common.